Problem 24, Chapter 18, Giancoli 6th edition. So we have a wire that has length 10 meters. So let me try to make a drawing here of this wire. Its whole length is 10 meters, but it's divided in two pieces. One piece is made of copper, it's 5 meters, and the other piece is made of aluminum. So this piece here, 5 meters, is made out of copper, and this other piece here, also 5 meters, is made of aluminum. And this whole wire is connected to a battery. So let me make this connection here with our battery. And this potential difference of the battery is also giving it's 85 millivolts. Okay, so this potential difference between the high potential and the low potential is 85 millivolts. We also know that the diameter of this wire does not change. The diameter is the same throughout. The diameter of this wire is 1 millimeters, which means that the radius is 0.5 millimeters. So with this radius, we can find the area, the cross section of that wire, which is the same for copper, is the same for aluminum. Let me see here. The area is the same for the piece of copper, is the same for the piece of the aluminum. Now this radius does not change, so this area is just pi r squared. Let's keep that here. We know the length, as we said, is 5 meters each piece, and then comes the question. What is the total resistance? And they give us a hint, no? The total resistance of these two wires. They put the word sum, meaning the total resistance will be the sum of the resistance from the piece of copper plus the resistance for the piece of aluminum. The idea is the current is trying to pass, and it finds resistance when it goes through copper, and it finds resistance as it goes through aluminum. It has no other way to go. It has to pass through both, so the two resistance will add up. Okay, so to find this resistance, this total resistance, I will add the resistance from copper and the resistance from aluminum. What is the expression for resistance? Well, resistance, we know that it's given by the resistivity, so for copper, the resistivity of copper, multiplied by the length of that piece of copper, divided by the area for that piece of copper, which is the same as the area of aluminum. We already obtained it here. Okay, so for the piece of aluminum, I will have to look in a table for the resistivity of aluminum, the length for the aluminum, which is 5 meters, and divided by the area. So that's what we need to find the total resistance. The next question is, now that we have the total resistance, what is the current that goes through this whole circuit and that passes through these both resistance? Well, to find the current, I'm going to use our equation, the potential difference is resistance I. So this current will be the potential difference 85 millivolts, careful here with the units, not pass it to volts, divided by that total resistance. And that's how we find the current. The next question is, what are the voltage across the aluminum part and across the copper part? So let's think a little bit about this. At this point here, we have high potential, and this potential goes on decreasing throughout. It goes on, decreases until I reach this other point where the potential is smaller. This is the potential difference established by the battery. Once I connect these two sides with the wire, I will get a current, and throughout this wire, this potential goes on decreasing until I reach the minimum side. Now, the amount of the potential that we find here before reaching the copper, this drop in potential is very small, so it's practically the same. The big first drop of potential happens when we really go through the resistance of the copper. Now you can imagine that here as we had a very long wire that gives enough chance, enough resistance for the potential really to drop. Now, so I can call this point here a certain potential A, which is more or less the same here, more or less the same. The drop is very small, but a big drop will happen once I cross the copper. So this I'll call VB. And then again, at the aluminum, I can think of this part as a long wire that gives the chance really for a lot of resistance to be shown, and therefore for a big potential drop to occur. And then here will be very close to VC. But of course, it's decreasing, but very close. And this is the lower potential. Very well. So the question is, what is this potential difference for the copper part? What is VA minus VB? Okay, so the question, what is the potential difference for that part of the copper, between the two extremes of the copper? Well, what we want to know is what is VA minus VB. All that we need is the current. Okay, the current is going to go through the whole wire. It has no other place to go. So the current that we computed here is the same current that goes through the copper and is the same current that goes through aluminum. So what I need is just this current multiplied by the resistance of the copper that we already obtained. And if you want to find the potential difference for the aluminum piece between the two extremes of the aluminum, that's going to be VB minus VC. And what is it going to be? The current, the same current, because the current goes everywhere. Now it doesn't have any other place to escape, multiplied by the resistance of the aluminum. And that's the idea of this problem. Now the whole potential difference, VA minus VC, will be the potential difference for the copper and the potential difference for the aluminum.